All right. Okay. Got two prisms set up. It refracts, refracts. This one refracts, refracts. Okay. So the similarities between these arrangement of prisms and this lens is skinny, thin on the top, thick in the middle. So when light rays pass through, just like your optical toy box, light rays bend in towards each other to refract at a, this is our focal point. Okay, this is known as a converging lens. Brings the light rays together, converges them. Okay, this, if you've ever played with magnifying glasses and magnifying lenses, this is where you burn ants with the sun. This is where you catch, like, start things on fire when you have rays going through the sun, or rays from the sun going parallel through the lens. All right, on me. Thank you. All right, so we're going to do some ray diagrams, your favorite things. Okay. There are some similarities and some differences between the ray diagrams we did with spherical mirrors and what we're going to do with lenses. Okay. Similarities. There are 3 rays of light that we care about. And they have similar characteristics or patterns. The similarity. Another similarity is the equations are identical. One over the object distance plus 1 over the image distance is equal to 1 over the focal length. And magnification is equal to the ratio of the height of the image over the height of the object. It's also equal to the negative image distance over the object distance. Okay. Differences. Light reflects, bounces off of mirrors, but refracts or passes through lenses. Okay. Good there. So I'm gonna give you a help expedite this process, I've given us printed off the stage for these things. So if you would like a straight edge, grab one of those up here. If you want to get out multiple colors, go ahead and get those out.
Yeah, it's like a normal one. How many colors do we need?
Three. Three colors.
No, I didn't say it. Yes, you wanted to. You literally could say that. I thought you said I'll get you one. No, Lexi got two. No. Okay, is anyone else want one? There's a dumb wrapper.
All right.
You use the same colors that you used before. Red, green, orange. Did you say your favorite?
I know, but it doesn't show up. Like the camera doesn't show. Like I looked at it, it's like these pop. Red, green, and blue. Okay, here we go. Yeah, oh yeah. You just need three. All right. You still have your principal axis. You've got your object. Okay, note this. I've got a focal point here, but I also have a second focal point. What's the deal? So I can go this way. I could also shine light going this way. So I get two focal points. I don't have a center. Okay. So ray number one, parallel to the principal axis. And then you take a stab at which way that goes. Okay, if this was a mirror, it would reflect through the focal point, but it's a lens, so it refracts or passes through and goes through the far focal point. Okay. Ray number two is going to capitalize on this reverse path. So if I send a ray of light through the near focal point, it's going to refract parallel. It just reverses that path. Okay. So what I'm going to do is I'm going to send a ray of light through the near focal point, and then it's going to refract how? It's going to refract parallel to the principal axis.
yearbook. I have this for student request.
Yep. Thank you much. Okay. The last ray is my personal favorite. So there's no center. Our center point that we're going to use for lenses is actually right there. Okay? We're going to shoot this at the center. Okay? Now, here's the full story, but at the end of the day, I'll just show you. Here's what you do. Because this is above the principal axis, this is going to cause the ray to shift down, refract down just a tad. And then when it comes out, it's coming out below the principal axis, so it's going to cause it to refract back up. If this is skinny enough, which these will always be skinny enough in this class, we're just going to approximate in a straight line all the way through. Okay? So to draw it, just put your ruler right here and just go. And that's done. Straight line through. Just
keep going.
Just keep on going. And hopefully they all intersect at the same point. Just go all the way through.
So the one that goes through center is like the one that goes through.
Okay?
So you just said keep going?
Yep.
But my Oh, okay. I just had it lined up.
Okay? Everybody good? So, where they intersect, that is your image. That's where your image is located. Tell your neighbor the characteristics of this image.
I think I can't remember the word for it, but the opposite of no, not really. She has daughters. Yes. It's like that and they go back. It's inverted. It like goes through and then it goes. It's I don't know.
Okay, here are your images. Inverted, meaning it's upside down. It's shrunken, meaning it's smaller than your object. So this is compared to your object, it's upside down. It's smaller than your object, so it's shrunken. And the light rays actually intersect, so it is real. Okay? Now, today I'm actually going to show you what real means. Okay? Now, to do this, you'll need a lens. Take one, pass one. Let's go ahead and pass both those back. Pass both those back. Pass both of them back, or all three. You just keep one.
So yeah, and that's why we have 11 cameras that we're here. This is how I see you.
Okay. Now we've got an object that's far away from the focal point. So wink, hold it at arm's length, and look at something far away. I know, right? It's crazy. Oh.
Well, that's just
Yeah, upside down. Oh. Okay, now here's what I want you to do to demonstrate real. I want you to do what I do. Hey, so you're sitting here all studious like. What I want you to do is I want you to rotate your legs and your shoulders so you're facing that way. Have your lens in the right hand, your paper that you're drawing the rays on the other one, flip it over so it's just a blank piece of paper and hold it like this, and you're going to be adjusting as so. Okay? Everybody good? Everybody got that position? Okay, you're not seeing anything yet. Just hold on.
I see the light.
I'll show you momentarily. You go until you see an image on the paper. Make sure you're not directly behind someone else's screen, otherwise you're in their shadow. How would you describe my image? Upside down, shrunken, and the fact that you can project it on a screen means that it is real. Okay? That's the consequence of being real. You can actually project it on a screen. A virtual image you cannot project on a screen. Your brain just puts it together. Okay? It's small. The object is smaller than your object.
Oh. Sorry, I did.
I don't know if you can see that. It looks cooler when I'm there standing, but anyway, there you go. Yep.
How do you know?
I would make sure you
Height.
Okay, and then what is? Oh, and inverted is
Upside down. Yep.
And real is they all cross.
Yep. Okay. All right. Here come the lights. All right.
I really appreciate that.
Follow-up question. Did the image form at the focal point? Did the image form at the focal point? No. That is a popular misconception. Here's the focal point. Here's the image. No, it's good. We're good. Good with that? Okay. All right. Now we're going to stick the object within the focal point. Okay. Draw the first ray. Draw the first ray.
Like if it goes like this, then I feel like the first line is I gave you like okay, fine. What?
Okay. First line goes parallel and then refracts through the far focal point. Okay? Second one. Yep. The second line goes through the near focal point. But if we try to like line up a ruler with the top of the object and the near focal point, we're like, oh, that completely misses. So I don't know if you remember doing this with the mirrors, but what we're going to do is we're going to connect the focal point and the top of the object. And then we project it. We're like, bump, 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 coming from the top of the object as if it came through the focal point, near focal point. And then how's that going to refract? It's going to refract parallel the principal axis. Okay, go ahead and draw the third ray.
The fact that you have to say that kind of says something.
Okay, straight through the center. Are we good? Straight through. What do you observe? What do you notice? There's no intersection. So what do we do? Yep. If rays don't intersect, then extend refracted rays backwards. And what this means is it is virtual. It's a virtual image, okay? So go ahead and if you're nervous to commit, just mentally extend the refractor rays backwards. Like which ones are you going to refract or extend backwards? Here we go. Here's the red one. Which one's refracted, A or B? B. So I'm going to extend the refracted ray backwards. That's what I mean by that. Okay. Dashes. No. Just don't make a solid line. But that's what this means. We're extending it. Okay. So
you guys just keep kidding with me, though.
well, didn't do that exactly right, but
Wait, why didn't it? Oh, like that.
okay. So ideally, they'd all intersect at the same point.
Yeah, mine didn't either.
Mine didn't either.
Mine looks like yours. I think the thing is wrong.
It could be.
It is.
Well, that's just kind of awkward because I wrote
Okay.
two of mine.
So
Two of mine go through the.
3 characteristics of the image. Tell your neighbor.
Well, wait, are they supposed to intersect?
Be close. Yeah.
If the green one was a bit higher, it'd be right here.
Yeah.
Okay, so it's virtual. Like, what is opposite? What?
Upright.
What?
Upright.
Upright. Right. And still, I
Okay. Upright, enlarged, and virtual. Good with that? Okay. How's this demonstrated? This is actually how we use magnifying glasses for just normal purposes. Take the magnifying glass, the lens, the converging lens, and hold it near your paper. Okay. And that image should be enlarged, upright, and virtual. That just means you can't put it on a screen. Your brain puts it together. Good with that? Good. Okay. Okay. If you could, I'm gonna pass the bucket. Deposit that lens gently in there. Here we go. Yeah. Talk about it on Monday. Okay. No, that won't. We got this one, last one. We're done with those lenses. What are they meet parallel lines coming in meet. It's a focal point. This. And these, where all these converge.
But what is it on the other side?
Okay. Does everybody see how this arrangement of the prisms models are similar to this diverging lens? Thick on the top and bottom, thin in the middle. Refracts, 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 refracts. Are we good?
Yes.
Okay. So when these guys go through, these diverge as if they came from a single point. That's the focal point. This is known as a diverging lens. Does that make sense? It's a diverging lens. Okay. Now, to draw this, if I could give like a one-liner piece of advice, how it compares to converging, is the role of the near and far focal points are flipped. The role of the near and far focal point is flipped on a diverging lens. First array. Goes parallel. If this was a converging lens, then it would go through the far focal point. But it's diverging, so it's as if it comes from the near focal point. Nope. Oh, never mind. Because it goes through it. Does that make sense?
How does it go to it?
As if it comes out of the near focal point.
So you just draw it from the focal point, lead it there, and then continue on through.
Yeah, give it a little dash, something like that. So like when you look at it, you're like, oh, okay. I see what I did.
You made it so much worse.
Hey!
I got paper towels. All right. Next ray reverses this. We're shooting at the far focal point and it refracts parallel. So to do this one, this is the most complicated one in my opinion. I'm shooting at the far focal point. So I'm like lining up my straight edge like this. Okay. So it's going through the far focal point. And then it's going to refract how? Parallel. Okay. And then the third one's the easy one. Straight through the center. Okay. Now, do the rays intersect? Nope. So what do you need to do? Extend the refractory rays backwards. We did on this one. Okay. The red one's nice because the dotted line is already like guiding our path here. So extending that one back. The green one is just the green. Then the blue. Which one's refracted? A or B? B is refracted, so I'm extending the refracted ray backwards. and intersect there. Tell your neighbor. Okay, I only have 4 of these, so you're gonna have to like share. But these diverging lenses, just kind of hold them out ish. You can look through it with 2 eyes, it gets a little dizzying. 1 eye works out well.
Wait, what makes it virtual?
The fact that you have to extend the refractive rays.
I need purple one.
Mm-hmm. So here's our
Yeah, I
object.
like the arrows.
Which one's bigger?
Oh, so it doesn't matter if they're both pointing up.
That's upright.
I know that means upright, but like in terms of like shrunken or.
Yeah, no, it's just the size of them.
Okay, that makes sense.
Yep. So you've got upright, shrunken, and virtual. What makes it what? It's upright if they're both like not one's. It's like right side up versus upside down. Yep.
Wait, but what if? No, but if they're both pointing down, then it's still upright.
Yeah.
Yeah, they just have to go the same.
Do what?
But they're far away.
Yeah. Okay. Good with that. So that's passed around. Oh, I need. All right. I have
Something today.
printed the worksheet for you. Due tomorrow.
Oh.
It is.
I can give it to you whenever I get done.
Yep.
The legendary.
So I don't want to get till Monday off.
That's virtual.
Yeah. Okay.
Upright means the arrow is facing up, and so is the image. It's right side up versus upside down.
How long is my dancer anyway?
It was like 3 minutes.
Okay, on Mondays it's like 8:30. Because I have my AP test Tuesday, so
It says 1:30.
Fair enough.
It was
flying. Crossword and crossword are my favorite points.
I agree. I won't be here tomorrow, but I'll come in with Kate when she turns her thing in.
Okay.
Do you want these?
Oh.
I'll find it. Oh, is that all it is?
No, it's not.
So you guys have like 10 minutes. Here's a diverging.